Okay, this is a short take from me showing how I would get the points on a IGCSE Marine paper 2, and this is paper 22 from June last year. And I'll just, with my badly skills in paint, show you how I'll get the point. Any mistakes here and mine alone, and does never ever reflect on Cambridge or my school. Thank you for watching. All right, so our first question here shows the geomorphology of the seabed for an area in the Pacific Ocean that extends from the continental landmass. So, you see up here, we have the shelf. So A here must be where it goes down, it slopes down, so it's the continental slope. B here we see is a large flat area at the bottom of the ocean, actually the largest ecosystem, the abyssal plain. And here we see we have hot magma coming up. So this here is you can say it's a ridge, underwater volcano. So our next question here, they ask about how our present-day continents and oceans are a result of movement of the tectonic plates. Outline how tectonic plate theory explains the formation of present-day continents and ocean. Quite a few students who just wrote like the continent of the plates move, which is correct, but we want 3 points, so I will write something like this. That continents start together as Pangea, supercontinent. Plates move on top of the convection currents of the hot mantle, causing the crust to move. So over 100 million years, the supercontinent broke up, and our current continents and ocean were formed by this movement of landmass. Right. This is one of the questions where they show us here that the direction of speed of oceanic currents are affected by the geomorphology of the seabed. And a student compares the speed of a current, oceanic current, by a rocky shore 3 different times a day. And here you see, first time here at 6 o'clock he gets this, and 12 o'clock he gets this, and at 18 we haven't calculated yet. We're told here our measurements for 18 are here. We have 3 different measurements, and we are then asked to find the mean current. So we say we have 0.4 plus 0.9 plus 0.6, and we divide that by 3. And then our mean current speed is 0.6 when we give our answer to 1 decimal place, and I have showed my workings here. Then they ask to describe a method to measure the speed of a water current, and this is actually mentioned exactly on page 76 in the book, how you do that. But since it's 4 points, we have to be a little specific to get all 4 points, and I would write something like this. That to measure speed, we need time and distance. Speed of surface current can be measured by adding a floating object to the surface and record the time. Then at a later time, pick up the object and record the time used and the distance traveled. We can then calculate the speed as distance divided by time. Repeat several times to remove errors. Another easier way is to add a GPS tracker to the floating object and track the time and distance traveled in real time. So we're told here that the student concludes that the speed of water currents is the same at all times of day and night. We are to evaluate the student's conclusion using the data in table 1.1 and table 1.2 to support our answers. And well, I'll say that the fact that all recorded speeds are almost the same here supports the idea, but there are no data for the night, and we only have 3 data points for the entire data set. So these two are things to be against making any clear conclusions from the available data. And to be honest, I'll say just 3 points one day and you have nothing at night. It's pretty hard to make a conclusion just from these data. So mackerel are pelagic fish, means they are swimming in the ocean, often caught by using purse seine nets. And we have to describe how purse seine net fishing is done. I will describe it as something like this. Well, the net is released from the boat into the sea. The boat then makes a circle to surround the fish with the net. Ropes are pulled so we can close the net, close the bottom, and then the entire net with the fish is dragged onto the boat and the fish are then caught. And if anyone remembers Finding Nemo, that's exactly what happens in the end of Finding Nemo, where the fish kind of swim down and Nemo is free. Finding Nemo, always a great movie. So here we are shown the image of a mackerel. And in the space below, we are asked to make a large, accurate drawing and do not include the markings. Okay, I'm drawing this with a scratch pen on my computer. This is going to be terrible, but hopefully you get the idea. The important thing is, first of all, we need to kind of get the body shape here, right? We need to have the tail to be big. Behind it, kind of have to get that fish shape going here. So 1 point from having unbroken line, and then I need to draw here. We have a mouth, we have an eye, we have a gill cover here, we have a little fin here, and that's about it. We can draw here. We can draw the small fins here. But important is there's no shading, no color. The size should be correct. The tail should be big, and you can see the shape should be correct. You should have the eye, the mouth, small fin here, all in the right position. I know this is a terrible drawing, and you probably, hopefully, do a lot better on paper than I do here on the scratch pad. So then we are asked to name the fin, and it's a caudal fin. And the main thing you do is you thrust or forward movement. Of our fish. So as always, when there are one of these questions where they ask about drawing something, they'll always ask about magnification, or at least they've done so many times now. And this is why it's important to have a ruler with you here, so you can actually measure the length there of the line you see in the figure. And then, well, you get 1 point from measuring the length of line X. I don't have your ruler here. And you get then 1 point from division of the length by 0.85, since this is what we have here. So whatever data you get out from this, from your measurement, and then have in centimeters, will be your answer, and you get your 2 points. So we are now asked to look here at classification. So here we have, this must mean up here we have domain. And since it's a mackerel, well, our kingdom are animals. And for genus and species, well, we are also lucky we use a binomial name. So we have here first the genus, and we have the species. So We're then told that our mackerel here live in the sunlight zone, which is the upper light here, part of the ocean, and we are asked to talk about two abiotic factors, conditions, of the sunlight zone. And I'll say, of course, the most important one is light. This is the entirety of the sunlight zone, that we are so high up that the visual light still penetrates the ocean. And I'll say low pressure. And I could also, now I'll have 2 points, but I can also say high oxygen saturation content. There we go. Easy 2 points. So we're here told that our mackerel is a typical fish that's living in the sunlight zone, and we should explain just one adaptation of fish species in the sunlight zone. And since I know the mackerel, I'll say one of them is they are fast swimmers. And that is to catch prey and avoid predation. You could also talk about that they have counter shading, that they're darker on the top and more light on the bottom, so the counter shading will make it harder for predators to catch them. You can talk about they are migratory. You can also talk about how they swim in huge numbers to make it harder for the predator to catch them. But I think fast swimmer is an easy way to get the points. So here we have a drawing of a zonation of our rocky zones here, and well, we are asked to name them. And in this case here, our X here is a subtidal zone. That's a zone that's covered by water all the time. Then we have here from low tide to high tide. That's our intertidal zone. And then up here above the high tide, we have our supratidal zone, or our splash zone. So our next question goes straight into the practical we see in practical 5.1, 5.2, where we have samplings. And here our student investigate the distribution of limpets and the macroalgae on a rocky shore, and the student carries out a systematic sampling of the species from the low tide level up to the high tide level. So we can see that the further we get up, well, the fewer numbers there are of limpets and the less cover there is. But that's not what we asked about. We are asked to outline a systematic sampling method to collect the results we see here. So the way I would write an answer like this is something like this. So I would start out by laying out a transect on the beach, and then I use the quadrants for sampling, as we do in 5.1 and 5.2. I would then place a coordinate at regular intervals and measure the distance from the low tide mark, as you can see here, the low tide to the high tide, and I'll then count the number of limpets and also the number of the algae cover in each quadrant. And from that, I can get my data here. So the entire idea here is to use the sampling methods from chapter 5, especially practical 5.1, 5.2, 5.3, and show you know how to use them. So it's a good idea to read up on them. Then we're asked to suggest why the student measured the percentage cover, which I forgot to explain last time, and didn't count the numbers. Well, especially if we have a low tide, well, it's hard to separate the different macroalgae, so it's easier to count cover as hard to separate individuals. So easier to calculate. percentage of cover. Because if we are going around at low tide, the macroalgae would be lying down, and it will be hard just to see where does one algae stop and where does one begin. But when we have our quadrants, it's easy to go in and count. Okay, this many are covered, and then I can use that to calculate my percentage, also as we do in the 5.1, 5.2, and 5.3 practicals. So here comes the really good biology question, where we are to discuss reasons for the change we see in the number of limpets per square meter along the rocky shore. As we see, we go further up the coast, we see fewer limpets and we see fewer macroalgae. And well, we have to get 4 points, so we have to be kind of accurate here to get all 4 points. And I would write it something like this. So I'll say limpets are high near low tide level, just to state the obvious, as they're less likely to dry out if they're covered by water a longer time. Higher on the coast, they'll be less likely, less covered and more exposed. Okay. Limpets, they shelter under the seaweed, and they're more stable conditions lower down shore as the algae and the coast is covered by water, as the limpets like to stay wet. And limpets, they'll eat the seaweed here, so it's a food source for them. And there's also be less predation when you lower down the shore, less chance of being eaten by seabirds and other things. And limpets, they are not dislodged by the waves, so they can live in most areas of a rocky coast. So I think this is a good way to answer this. It might be a little too much, but I have the time and I want to make sure I get the 4 points. Lastly, we are asked about sea anemones, who are also found on rocky shores, and they mainly live in rock pools and crevices. Explain how sea anemones are adapted to live on a rocky shore, and I'll give an answer something like this. Well, on a rocky coast, sea anemones they live in rock pools and crevices, and sea anemones they tend to live under seaweed. Sea anemones use their tentacles for hunting, but when water levels are low, they can retract tentacles to avoid drying out. The base of our sea anemones, they attach themselves, here I forgot something, to the rocks. So sea anemones do not get dislodged or displaced by waves and tide.